Okay. All right, so all of that audio, and I'll try to figure out where this video starts, was what I've done here. So let's go sort of, in fact, I'll just erase all of this. I might actually even be able to snip some of that video once it's done. So I'll delete all this. So this is a picture of this mountain. H is the height of the mountain. The 27-degree angle is the farthest away from the mountain. Then 35-degree angle is 5,000 feet closer to the mountain. So that's the 5,000 in this picture. And then there's an unknown distance from the 35-degree angle to the, not to the mountain, but basically to the point directly under the top of the mountain is where that would be. Obviously, a mountain is not a single vertical line, but that's what I need in order to make it a right triangle. All right, so so basically what I had done when I didn't have video was I set the tangent of 35 degrees equal to opposite h over x adjacent. And then the tangent of 27 degrees is opposite h over adjacent 5,000 plus x. The entire base of the big right triangle is 5,000 plus x. All right, and then what I did was I solved the top equation for h so I could substitute that into the second equation. So I've got h equals x times the tangent of 35 degrees. And then I'm going to take that, x times tangent of 35, and plug it in for the h in the other equation. So that now I'll have an equation that only has x. So I'll have tangent of 27 degrees equals x times the tangent of 35 degrees over 5,000 plus x. All right, so now we just need to solve this equation for x, and once I get that, I'm going to plug it back in for the x, just multiply that by the tangent of 35 degrees, and that'll give me the height of the mountain. It is slightly, the algebra here is not too bad. It's a good skill to be able to do this algebra with the tangents still there. Those are numbers. But if you change them to numbers, you need to carry at least 4, maybe 5 significant figures. So it'll be messy. So the first step would be to multiply both sides by 5,000 plus x. So I'll have 5,000 plus x times the tangent of 27 degrees on the left. And on the right side, it'll just cancel. So I'll just have x times the tangent of 35 degrees. All right. On the left, I want to distribute. So I need to distribute that tangent. So I'll have 5,000 tangent of 27 degrees plus x times the tangent of 27 degrees equals x times the tangent of 35 degrees. Let me move my thing, my bottom one. Okay. All right, now when you're solving an equation, this is a linear equation. I need all my x's on the same side and all my things without x on the other side. So I'm going to subtract x tangent of 27. So I'll have 5,000 tangent of 27 degrees equals x times the tangent of 35 degrees minus x times the tangent of 27 degrees. And now I'm going to factor out the x. So the right side will become x, and then parentheses, tangent 35 degrees minus tangent of 27 degrees. And the left-hand side is still 5,000, tangent of 27 degrees. All right, and then the last step is just to divide by that parentheses, and that'll give you x. So I'm going to put the left-hand side over tangent of 35 degrees minus tangent of 27 degrees. And that's your x, and then you just go back up to the top and you substitute it in, and you multiply by the tangent of 35 degrees, and that will give you your h. All right. Questions from, where did they go? Where'd that go? Sorry. I need to. All right, questions from the people on the video or who are here about that question. All right.
I think I had that one okay.
Let's take a look at the bottom one, yeah. The second problem. So we got a plane flying 2,000 feet above sea level toward a mountain is shown. The pilot observes the top of the mountain is 16 degrees above the horizontal. So it's higher than he's flying. So he needs to make his angle higher still to make sure he goes over the mountain. So the airspeed of the plane is 100 miles an hour, which I don't think changes. And I don't think the 5 minutes changes either. So the hypotenuse of the big triangle is always going to be the same. Only the angles will change. And the 2,000 feet, I think, stays the same also. All right. So, so what I've got here, let's draw the vertical side to make my right triangle. All right. So the hypotenuse I can figure out by the speed of the plane for 5 minutes. So that's 100 miles per hour. Times 5 minutes is 1/12 of an hour. You could say times 5 over 60 if you wanted to. The one issue is we want everything to be in feet. So let's change once I get that, I need to change miles to feet. So let's see, this is 5 minutes. This is a fraction of an hour, sorry, 5/60th of an hour. And actually, if we want to do this so we can say miles here, per hour means that the hour would be on the bottom. This is 5/60th of an hour, so the hours would cancel. And then we need 5,280 feet per mile. So then the miles would cancel and I'd be left with feet. So let's go ahead and figure this out. Actually, let's see here. I'm going to bring up my calculator. Ooh. Let's see if I can get this on the same screen. I can't. Okay. Well, so it was 100. And it was 1/12 of an hour. So it's really just divided by 12 and then times 5280. So 44,000 feet is the hypotenuse of that triangle, of the big triangle, the beta triangle, call it. So 44,000. All right. Now I just sort of work my way around the triangle to find out what I want to know. So I need to know the right-hand side of both triangles, and the answer to the first question is 2,000. The height of the big triangle, the beta triangle, minus the height of the alpha triangle, and the answer to the second question is the height of the alpha triangle plus 2,000, because I still have 2,000 down here. And I've got h is the height of the small triangle. Call that h. Call this, say, x for the height of the big triangle. And we're going to need to find the base. Let's call it b for base. So let's find if I find the base first, I can sort of go around. I can find x, then I can find b, then I can find h. But if I find b, then I can use the same task to find both x and h. So for b, the best way to find it directly is cosine, because it's the adjacent side of the beta triangle over the hypotenuse. So if I say cosine beta, and beta in this case is 19 degrees, I'll put a beta over the top of it, that's equal to b over 44,000. So then b is just 44,000. 44,000 times cosine of 19 degrees. So if I go back to my little calculator, so that's times, I need my sine, where's my cosine? Up here. Oh, there it is. Times, I'm going to go, I'm in degree mode, 19 cosine, I think is how I have to do that, yeah. Equals, so 41,603. Since I'm going to round to the nearest 10 feet, rounding this to the nearest foot should give me plenty of accuracy. So 41,603 is the base. I'm going to write that. I'm going to erase the b now. Well, I'll just write it to the left of the b, 41,603. And now I can use, for h, I need to use that b. and that's opposite and adjacent. So the tangent of alpha, which is 16 degrees, is equal to opposite h over adjacent b, which is h over 41,603. So then h is 41,603 times tangent of 16 degrees. For x, you'll get a slightly more accurate answer if you use the hypotenuse of 44,000 because that was exact. So that would be sine. You could use tangent also with the base of 41,603, but if I do sine of 19 degrees and say that's equal to x over 44,000, then x equals 44,000, multiply the denominator times the sine of 19 degrees. And then, and so then I've got my x, I've got my h. The answer to the height of the plane above the mountain is just the difference of those two, x minus h. And then the total height of the mountain is h plus 2,000. So I'll leave you to finish those last couple of steps, but we've got everything we need at that point. It's just, now it's just typing things in your calculator. All right, so those were the questions I had in advance. What other questions did people have? The people who are here. Ooh, let's see, there's a chat. 4.1, number 7. So let's take a look at that, Scott. 4.1, so I have to go back here. One more step. For number 7. So this might not be exactly the same as yours, but it should be similar enough that the steps are almost the same. So I got cotangent t over cosecant t minus sine t. All right, cotangent t. T over cosecant t minus sine of t. All right, sometimes you can look for a Pythagorean identity, but there is no, and you can multiply by a conjugate, like in the base here. But cosecant and sine don't have a, Pythagorean identity. So the best thing I can do in this case is change everything to sines and cosines. So
I can only see your calculator.
Cosine, cotangent of t would be cosine of t over sine of t. That's the numerator. And cosecant of t would be 1 over sine of t. And then minus sine of t. Now there's two tacks at this point. One is to get a common denominator in the bottom and turn that into a single fraction and then multiply by the reciprocal. But I think even easier, since both the numerator and denominator of the big fraction have smaller fractions with denominators of sine, what I'm going to do,
we're looking at the calculator, by the way.
Bottom of this fraction by sine of t over sine of t. And I'm allowed to do that because sine of t over sine of t is 1, except when sine is 0.
We can't see the screen again.
Right, and what that will do, on top it will just completely cancel, and I'll just have cosine of t. On the bottom, you have to distribute to both terms. And when I multiply by 1 over sine of t, that'll just be 1. And when I multiply it by sine of t, that's sine squared of t.
No.
Now, 1 minus sine squared is my Pythagorean identity. That's equal to cosine squared of t. Well, now I have cosine over cosine squared, so I can cancel one cosine from the cosine on the top with one of the cosines on the bottom. And I get 1 over cosine t. And 1 over cosine is equal to secant of t.
That's great. What?
Oh, and I did it again. Ay. I stopped the screen sharing. Okay. I got to be more careful about that. Okay, so here is my version of the problem on the left. This was what was given in the problem. Okay. And my first step was to rewrite everything in terms of sine and cosine. So I already had sine in the bottom, but I changed cotangent to cosine over sine and cosecant to 1 over sine. right? And then I saw that I had denominators on the top and bottom of sine, so to cancel those out, I multiplied top and bottom by sine over sine. On top, it cancels and leaves cosine, right? And on the bottom, I distributed it, and sine of t times 1 over sine of t is 1. That's the first one here. And sine of t times sine of t gave me sine squared. And then I didn't write it down, but I'll write it now. Cosine squared of t plus sine squared of t is equal to 1. And if I subtract sine squared, cosine squared of t equals 1 minus sine squared t. And so that's how I changed 1 minus sine squared of t into cosine squared t. And then I could cancel a cosine, top and bottom, which leaves me with 1 over cosine t, which is secant of t. All right. Other questions?
Can we? I'm lost on all of 4.1. Really, can you just do like a question 1 or 2?
I know, generally speaking, nobody was there on Monday. I know it was a holiday, and also I know generally Mondays are not going to be as busy because homework is usually due on Fridays. But I know Sunday and Monday will be this Sunday and Monday will be rather popular because of the test on Monday. Right. Any other questions from? I mean, mostly it's probably going to be modules 3 or 4. Although if you've already started on the test review, you could ask questions from that.
Can you do like the 4.1?
I mean, there's really, I mean, the topics really are the main things you have to know for 4.1 in terms of these simplifying or verifying identities is you need to know how to change the trig functions that are not sine, cosine into sine and cosine. You need to know, like what we did just on the previous problem, that to clear out a fraction, an easy way to do that is to multiply top and bottom by the common denominator of your fractions, and that'll clear out all your fractions. Another thing you need to know is, let's say let's say you have something like 1 minus sine of t. And I don't know, let's say you have, it really doesn't matter what you have on top, but if you've got something else on top. If you multiply that by the conjugate, 1 minus sine of t, and of course you'd have to also multiply the top by the same thing, that will get you your Pythagorean identity on the bottom. Oops, sorry, that should be a plus, not a minus. You have the opposite side of the middle. That's what makes it a conjugate. So that will turn into 1 minus sine squared of t, which is cosine squared of t. Right? And that comes from the reason why that's equal is if you remember your difference of squares, if you have a plus b times a minus b, when you multiply that out, your middle terms drop out. You have a plus ab and a minus ab, so that's just equal to a squared minus b squared. So in this case, the a is 1 and the b is sine, so it just turns into 1 squared or 1 minus sine squared. So really, you're really getting into real math now, in a way of speaking, when there's no longer, you're used to in algebra, like here's how to solve this kind of problem. In this section, in 4.1, I can't say here's how you solve this kind of problem. I actually could have done the problem we just did in a different way. And another problem with a fraction might not have been able to be solved the way I solved this one. So you really just have to, sometimes you might try a method and it doesn't work and you have to try a different method. I wish I could give you a method that works for every problem, but that doesn't work in this case. You really have to be willing to try different things, and that's, the further you go in math, the more that happens. I teach courses all the way up to differential equations, and students, the further they go along, the more it becomes not just how do you apply a method, but hey, I've got different methods I could choose. How do I decide which method to use? And I could use more than one method. Which method is the best one to use? So, I mean, we could go through, if we looked at a couple of them, like here, right? So for this one, you might say, okay, well, I'm going to multiply by the cotangent. I could say is cosine over sine. Well, your best bet is to, in this case, get a common denominator because you got a single trig function plus a fraction. And once you do that, it'll come together pretty easily. If we pick another one. This one is another one where, like on the last one, 1 minus secant squared is a Pythagorean identity. I'm not sure that would be super helpful in this one. You'd have 1 plus 1 over cosine. So again, this is one where I, looking at it, don't know immediately what's going to be the easiest way to solve this problem. 1 plus cosine over 1 plus secant. So if I write it down, 1 plus cosine of, well, you want to keep the variable t again, over 1 plus secant. I'm going to try 1 over 1 plus 1 over cosine t. Let's see here. So what I might try doing is just what I did last time. I could try multiplying top and bottom by cosine of t. And on top, I distribute it. I get cosine of t times 1 is cosine of t. And cosine of t times cosine of t is cosine squared of t. And on the bottom, I get cosine of t times 1 is cosine of t plus, and then when I multiply it by its reciprocal, it's 1. So what I see here, actually, is you might not notice this at first. What I see is that I can, on the top, I've got two terms and I've got a cosine of t in them. I can factor that cosine of t out. When I factor that out, the first term is cosine of t out of factored with the cosine of t leaves 1. Cosine squared leaves plus cosine of t. And the bottom is cosine of t plus 1. And 1 plus cosine of t is the same thing as cosine of t plus 1, so those cancel, and the answer is just cosine of t. So honestly, it's really just trying different stuff. All right, so that's sort of, that's unfortunately the best I can tell you in this case. It's, you got to know your Pythagorean identities. You got to know how to change your tangent, cotangent, secant, cosecant into sine and cosine. You got to know how to multiply by conjugates to create Pythagorean identities. Those are probably the three biggest things. All right. What else? You can either use your audio or you can use the chat. And if you're working on these tomorrow, oh yeah, don't worry about the due date on the upper right here. When I changed the due date, basically it saw the original due date, so it thinks that's the original due date, and it thinks that I created an exception for everybody. So don't sweat the fact that mine says due Thursday, yours is due Friday, due tomorrow. So as you're working on this, and tomorrow, if you got questions, keep sending them to me. I'll be able to answer your questions tomorrow if you use the message instructor link. All right. If there is nothing else, I'm gonna go. I have another webinar for my other class, so. But if anybody does have a last minute question, now's the time to ask.
No, I just want to say thank you for the help. I just want to say thank you for the help you give us.
All right, everybody. Have a good night, and I will look forward to more questions from you tonight and tomorrow, and I'll make sure to answer those questions as quickly as I can. And I will send out an announcement on the time of the Sunday meeting shortly, probably sometime tomorrow. All right. Have a good night, and I will talk to you soon.